Lesson 47, graphing functions. If you remember, we talked about input and output numbers. The input numbers are our x values, our output numbers are the y values. We also call our input numbers the domain, and all the output numbers we get is called the range. The input numbers are also independent, and the output numbers are dependent because they depend on what we put in for x. So we're going to make a little function machine here. We're going to times 3 and then we're going to add 1. So we put in our input numbers. We're going to get out our output numbers. So let's do our x and our y table. Remember that x is our input, y is our output. So we'll just pick some input numbers. We'll start with 0, 1, 2, and 3. So we put in a 0, we're going to times it by 3, and we get 0 and add 1, and our output would be 1. If we put in a 1, we times it by 3, we get 3, then we add 1 and we come out with a 4. A 2, we input a 2, times it by 3, we get 6 and add 1, output is 7. And we put in a 3, times 3 is 9, plus 1 is 10. So the rule for functions is that for every input, there is only one output. If you remember, we can do the vertical line test to see if it's a function when we look just right at the graph. So for every input, there is only one output, exactly one. So we're going to look at an example, p equals 4s. Now, the p itself is going to be the output, and the variable s will be the input. So you might be asked, what is the domain? That means, what numbers can we put in for the s? Now, if we were talking about perimeter of squares, so let's pretend we're talking about perimeter of squares. The domain is going to be whole numbers. So it can be 0 and then all the positive numbers. So we can put in all the whole numbers. If we put in negatives, you just can't have a negative side length. So the domain is written in braces, and it's going to be whole numbers, a set of whole numbers. What is the range? Well, the lowest number we're going to get is 0, and then it can go up from there depending on what number we put in. So this is also going to be the whole numbers. So let's create a table of values for this function. So a table of values, we just put our input on the left, we get that from the right side of our equation, and the output on the right. So we're going to put 0, 1, 2, 3. Okay, now we can't put in any negatives because we can't have negative side lengths. So the perimeter, if the side 0 will be 0, if the side is 1 will be 4, if it's 2 it's going to be 2 times 4, which is 8, and if the side length is 3, the perimeter will be 12. Now let's graph this function. So it's going to be in the first quadrant because they're both positive. We'll This is going to be the side length. Oops, I wanted to do side length, count by ones, the perimeter, count by twos. So if we graph these points, we have 0, 0, 1, 4, 2, 8, 3, 12. We can connect it because we can have fractions of sides. We could have each side equal to 1/2, and then our perimeter would be 2. If each side was 2.5, our perimeter would be 10. So we can connect the dots to show that it's continuous. It's going to be a ray. I'm going to turn the page. And we're going to review direct proportion. Direct proportion is a function that aligns with the origin. So it has to align with the origin, and it has to be a straight line. So the perimeter example that we did on the previous page would have direct proportion. It is, the points are straight and they align with the origin. Align just means that they line right up with the origin. A continuous function is a graph that has no gaps or holes. So if I can draw the graph without picking up my pencil or pen, then it is a continuous function. If I start drawing and I have to pick up my pencil or my pen at all, then it's discontinuous. It would not be continuous. And that's the end of the lesson.